Okay, so we're starting 2-1, Unit 2, and it's all about functions and the domain, different types of functions, linear, quadratic, exponential, and the features. So we're going to first look at our relationships and functions dictionary. Um, these are key vocabulary words and visuals to help you to understand what we're doing. So coordinate plane is formed by the intersection of two number lines, the horizontal, which is the left-right, that's the horizontal, and the vertical, which is the north-south, so vertical. They make a 90-degree angle, so they make a T or a cross. The x-axis is the horizontal axis on the plane, so that is, again, the going east-west. The vertical axis is the y-axis. Okay, so when you create that x, you actually create 4 quadrants. You have quadrant 1, which is a positive x and positive y. We have quadrant 2, which is negative x but positive y. We have quadrant 3, which is negative x, negative y, and positive 4, which is positive x, negative y. So that's the type of numbers that you'll have in that particular thing. The origin, which is the centermost point of it's where the 0, 0 exists. That is called the origin. Ordered paired is how we identify any point on that, like the 0, 0. The first number is always the x. The second number is always the y. It doesn't matter if it's positive or negative. It will always be in that form, x, y. Think alphabet. A, B, C, D, X, Y, Z. So X always comes first. The X coordinate is the first number. So that's the X coordinate. Whenever we're doing the solving on the graph, remember we always use the X value for the answer because it is the solution to what we're looking for, and it's the X value. It's the X coordinate. Our second one is the Y coordinate. So if we had that 12, 7 on here, the Y coordinate would be the 7. So again, 7 is the Y coordinate. A discrete graph is a graph that consists of points that are not connected. So that would kind of look like this. Here's your graph, your axes, and you have points, but no lines. Okay? A continuous graph is one that has a line that is going continuously or a smooth curve, but does not have, it can have holes, but you're not jumping around all over the graph. Okay, a relation is a set of ordered pairs, any set. There's no specification. It just says we have 3 points. Those are ordered pairs, x, y, x, y, x, y. That's all it makes a relation. A domain is all of the x values in that relation or function. Now here's the deal. You must write them in numeric order, least to greatest. Okay? The range is the y values in any graph or function or list of ordered pairs. So, and again, we should be writing these. That's not right. We should be writing them -2, 4, 6, even though that's not the order they came in, least to greatest. That's our range. Okay? So always list least to greatest. You will get it wrong if you do not do that. Okay? It actually helps us to know when we're doing our more complicated ranges and domains, we always look from the least to greatest. Okay? So mapping is one way to illustrate where each domain point links to, the y that it links to. So -1 is linking to -4, so technically we would have a -1, 4. 0 is linking to 6, so we would have 0, 6. 5 is linking to -2, so we would have 5, -2. So this is ordered paired list out. This is called mapping. This is called a map. Like you're learning to go from point A to point B, and you draw yourself a kind of like a directions to go. A function is a relationship in which each x does not repeat. Key there. X's do not repeat. Only one y per x. Okay? So you can only have one y for every x. You can't have more than one y for every x. So just keep that in mind. All right, function notation is where we rewrite the y with the f of x. So this is, they mean the same thing, but we are just saying a function of x. Something is happening to x and it's going through an input. It's going to go through this and it's going to come out with a y. Same difference. It's just it means function of x. So every time you see the words function of, they're talking about this kind of idea. Okay, an input is the number that's being put into the equation to find out what the answer would be. The output is what comes out as the output, as the answer. So input is x's, output is y's. So that's how you can remember it. Okay, the vertical line test is a test to check to see if something is a function. So if you drew a dotted line anywhere through the graph and you touch the graph in more than one place, it's not a function. So this one touches here and then touches here, so it's not a function. This one doesn't touch anywhere, no matter where we draw the line, in two places, so that one is a function. Sorry about the phone call. All right, zeros is the place at which the function crosses the x-axis. Now, zeros have other names. Zeros are also called x-intercepts. They are also called, what was the other one? Roots. These are all words that mean the same thing. And where they are is where y is equal to 0. So they're x's when y is equal to 0. That's what you're trying to figure out. All right, arithmetic sequence is a sequence of numbers that increases or decreases at a constant rate. So if you notice, we're adding 3 all the time. So we could just keep doing that and we would have an arithmetic sequence. A common difference is a difference between consecutive terms. So between 1 and 4, you added 3. Between 4 and 7, you added 3. Here, we're going 15 to 11, that's subtracting 4. So our common difference is what we're either adding or what we're subtracting. An arithmetic formula is a formula that tells us any number on that list of numbers. If we know the starting point, the first number, and what we're adding or subtracting by, and how many times we did it. Okay, so if we wanted to take 1, 4, 7, 10 and figure out what the sixth number is, so for one, when n is 6, that's the placement value. For 1, 4, 7, 10, this is place 1, let's place 2, that's place 3, place 4. We don't know what 5 is, and we want to know what 6 is. That's what we're trying to find. So we can actually put it in here and say, okay, place value at 6, that number that we're looking for, we know what the first spot was, that was 1. And we know what we're adding by 3 each time. Sorry, 1 plus 3. And then we want to go to, and what n was 6, because we're going to place 6 minus 1, and that will tell us what our answer is. 1 plus 3 times 5. So we should be at 15 plus 1 is 16. And we can check that by going add 3 more to here, that's 3, plus 3 more here, that's 16. So it's just a way to kind of skip over listing every single thing out. Okay. So now that we've gone over some vocabulary, we're going to look at the coordinate plane a little bit closer. A plane divided into 4 coordinates used for graphing. We just talked about that. So we have the 4 planes, or the 4 quadrants, rather. We have our x-axis. Oops. We have our y-axis. And then we have the origin, which again is 0, 0. Okay, and then we have the ordered pair, which is again x, y on the graph. So if we wanted to find the ordered pair for A, we would go count from the center, from that origin, 1, 2, 3 back. That's negative. It's on the negative side. So that's negative 3. And then we go 1, 2, 3, 4, positive 4 because we went up. So that's negative 3, positive 4. And that's in quadrant 2. And we would do that for each one of those different graphs. So check your points, make sure I'm not wrong. Remember, if you catch me wrong, I give you an extra 100. Discrete graph is one where all the dots are just kind of all over the place. There's no lines involved. And again, a continuous graph is one in which lines or curves are involved. Okay, so here is the different ways that we can look at relations and determine if they are what their domain or range, and whether or not they are functions. So a relationship is a set of ordered pairs. The set of x's is the domain. The set of y's is the range. We remember that by thinking of Dixie Roy. I can't write this. D-I-X-I. So Dixie is domain, input, x values, and it's the independent. Royd is the range, the output, the y values, and it is dependent, like you are to your parents to take care of you. So your parents are independent because they have their own job, they're adults, etc. You are dependent, you are the child. So here's the way to remember this. You depend on your parents. So your parents give you money so that you can buy food. They're the domain, you're the range. Okay, so domain here would be -3, -2, +1, +3, and since there's another -3, we don't have to write that twice. So don't write double negatives. We don't write this twice. If there's 2 of the same thing, don't write it twice. So, and then on our range, we're going to find the lowest number, which in this case is -4. And then go to the next lowest, 0, next lowest 1, next lowest 2. There's no 2, oh, 2. And the next lowest is 5. Put them in numeric order. So if we did that as a table, we would simply write them, instead of in parentheses, we would write them x's and then y's. If we did it on mapping, we'd put all of our x's here and then draw arrows where all those match. So here's where you can see there's 2 -3s, or -3 mapping to 2 different numbers. And then if we were putting it on the graph, we would go over to -3, over to -3, and up to 1 to find that -3 one. Okay? On the next one, again, mapping, or writing out all your x's. So your x's is -2, -1, 0, 2, and 5. And then your y's, we go with the smallest, -4, -3, -1, oops, -2, -1, and 4. So these are the ranges, and these are the x's. Okay, So then we can put it in a table, we can use mapping, and we can use dots. And then we have another final example. Again, we have ordered pairs, tables, mapping, graph. Those are the 4 ways that we can actually show what's going on with a relation and with a function.